Hey everybody, how's it going? Alright, so the last video we watched was solving absolute value equations. In this one, we're going to talk about inequalities. Now, if you remember, an inequality is going to have a whole range of solutions. It's not just one number. Generally, it's going to be an entire interval of answers or solutions that make an inequality true. And I want to just talk for a minute about, oops, wrong page, how inequalities work and exactly what the language means when you see symbols like this. They can be daunting to understand sometimes, and let's try to wrap our head around this thing. It says, consider this statement: the absolute value of x is greater than 2. Now, and I highlighted this in the notes. This means the distance from 0 to x on the number line is more than 2 units. All right, so what that really means, where can I be more than 2 units from 0? Well, anywhere inside here from 0 to 2 is less than 2 units. Now, we're specifically told to be more and not including it. So from 2 out is more than 2 units from 0. Similarly, from -2 out towards negative infinity is also more than 2 units from 0. So this solution set is a compound inequality. X has to be less than -2, or it could be greater than 2. And we could write that in interval notation if we wanted to. All right. So that leads to the following formula, and that's one way to solve these, is using this simple little formula here. It says to solve the equation, which is not an equation, it's an inequality, and we'll update that right now. Solve the compound inequality, ax plus b is less than -c, or ax plus b is greater than c. All right, so I want to show you how to use this formula. So basically what you're doing, now pay attention to this. You take the stuff inside there. It could be a linear expression in our case. You're going to make one of them less than the negative, just like the picture up here. In fact, you can memorize this formula just by understanding this. One's less than the negative, one's greater than the positive. And you can see less than the negative, greater than the positive. Solve both of them and you'll have the solution. So let's knock this one. Let's knock this one out. I'll show you how to set this thing up. And it would look like this. 2 absolute value of x minus 2 plus 8, and that's greater than or equal to 11. All right, first of all, this is not in the form we need. This is not saying that we have something greater than or equal to c, right? It doesn't say that. So I need to put it in that form. So I'm going to treat this absolute value expression kind of like a variable and isolate it, all right? So I can subtract 8 from both sides. And that gives me 2 absolute value of x minus 2 is greater than or equal to 3. Then we're going to divide by 2 on both sides to get to that. Right? Now we're in the right form, and we use our formula that says ax plus b is less than -c, or ax plus b is greater than c. So we're going to drop the bars, and we'll have x minus 2 is less than -3/2, and I guess or equal to, I got to be careful with that, or x minus 2 is greater than or equal to 3/2. All right, let's work on one at a time here. This one I just add 2 to both sides, right? Plus 2, and then I get x is less than or equal to, that's going to give me positive 1/2, right? Or come over here, we add 2, add 2, and we get x is greater than or equal to 7/2. So that's your solution set. In interval notation, -infinity to 1/2, union 7/2 to infinity. All right, if you thought that was tough, I have an alternate method. Really, the first part of it is cleaning it up. Set 1 equal to the negative, or no, less than or equal to the negative, greater than or equal to the positive. I'm sorry that looked like a -2 there. That's why I paused for a second. I'm like, what did I write there? Why did I do that? That's part of that symbol, and it got kind of messy. I apologize for that. Let me show you something you're really, really going to like. I know you're going to like this. We all like shortcuts. Remote learning is fun and everything, but when you can take a shortcut, you know you want to do it. All right, pay attention to this. Look closely. Go to your Desmos. Notice I typed that inequality in just like it looked. Graph it. Okay, let's interpret this. And I'll tell you something. When a thing gets out of control like that, you can hit home and bring it right back into focus. All right, so what we're looking at here, and remember our solution set said -infinity to 1/2. Now, the shaded region is an inequality is the solution set. So what we're looking at, look at this as sort of like the number line, the x-axis. And if you want to zoom way out, you're going to notice that it just keeps going to infinity, right? It does, in both directions. So from -infinity to 1/2, union, that turns out to be 3/2, or not 3/2, 3.5 to infinity. Okay, so maybe the fractions are a little bit confusing with this particular graph here, but you can see that's 0.5. You zoom in, and that's 3.5. So that gets you that same interval of numbers just using a graph in Desmos, okay?